Welcome! In this series of videos, we will cover the design and implementation of a project from initial design through coding and development to testing, using both the PowerBasic Console and Windows compilers. Today, we will create a UDP link to communicate between the task leader and task worker computers. As each of the computers that are defined as task workers need to be able to communicate back to the task leader, and to achieve this, we are going to use a UDP link. This will allow the status of each task worker core process to be reported back to the controlling task leader computer. In this project, we will be reusing many of the libraries and coding techniques already covered in previous videos. In today's video, we're going to make a start on both the task leader and the task worker applications. The task leader application is going to be a PowerBasic Windows compiled application. The task worker is going to be a console compiler application. I've done some pre-work on the task leader. What you see before you is the main dialog of the task leader process. This has only 3 objects on it. It has a text box, which is read-only for the number of workers currently active. It has an activity read-only text box, which is designed to be multi-line. And it has an exit button. Below the workers active box, we're going to have a grid, which will dynamically report on the activity of all the task workers. But we'll add that in a later video. What we're doing today is establishing the link between this application we're seeing now, the task leader application, and the task worker application, and that's going to be by a UDP link. So let's have a look at the code. At the beginning of the application are the normal Windows includes, for our Windows 32 API, the common controls, and for the PB forms. Below this, we're setting some constants and some globals. We're setting the maximum number of workers to be 500. This can always be increased later, but 500 is a reasonable number to begin with. And we're going to maintain a global variable that keeps track of the total number of workers that are currently active. I've also created a user-defined type, UDT workers. This will keep track of the worker name and their current condition. The current condition being a number, either active, processing, or not active. Active would be awaiting work, processing would be currently processing work, and not active would be not available for work. We may add to these conditions later on in the project. We have created a global array for the workers as a UDT workers array, which is this user-defined type. So in the PB main function, our first task is to dimension this workers array for the maximum number of workers, which is currently 500. And then after initializing the PB forms, we'll go straight to the form itself. So this is the basis of our task leader application. If we have a look at the event handler, the callback function, we'll see in here we are using a timer. This timer is going to trigger every 10 seconds, 10,000 milliseconds. And as we've used timers before, you will see that we have a timer section further down. And this is a piece of code that's going to trigger every 10 seconds. And this will populate the total number of workers based on this global variable for the total number of workers active. And the other piece of code we've got in is the functionality of the abort button, the exit button. So we'll just put in a dialog end command in here for the moment. So we run our application now. When we click the exit button, it will exit quite happily. As some of the projects you will be undertaking might be quite complicated, it's best to develop, test, and debug as an iterative process. Using that approach, you will be testing as you go, and there should be no surprises later on in the code. It's always much harder to debug a project that has had no debugging during its development. So as we said earlier, we're going to be adding some libraries we've developed before to save time in coding. The first of these is going to be our PB Processes library. Since this particular application, the task leader, will only be running on one computer, you only want it running once. You don't want it running twice, as this would cause some confusion. So we're going to include this library at the beginning of our code. If we have a look at the library itself, we can see the part of code we're going to be using. We want to call the funProcessCount function. This is to determine if the application that is currently running is already running. So we can copy this example call straight into our code. And this will be the first test we actually do. If the number of processes that match the current application name is greater than 1, then there must already be a task leader running. And at that point, we just want to exit the application. So this will avoid 2 processes running at the same time. The other library we're going to add today is a new library called UDP Comms. This is going to contain our code to allow us to use UDP. This library has a number of globals set up at the beginning. One to hold the name of the currently running computer, one to hold the name of the UDP server, and a number of functions. We'll cover these functions as we come to them. We're going to add some more globals at the beginning of our application. We already have one that keeps track of the number of workers currently active. We're going to add 3 more. One as a global flag to allow us to flag to the background thread which we're about to create that is now ending. One for a global thread handle and one for a dialog handle globally. If we have a look where our dialog has been set up, this populates a handle which is local to this particular process. I'm going to store that local handle in a global handle so we can access it from anywhere in the application. Quick compile to make sure we're okay. Since this application will have a dialog which is constantly visible and being updated to a user, and will also in the background be running other processing, we don't want the other processing at the back end of the application to actually delay the updates to the screen. So to allow these 2 separate functions to operate independently, we're going to create a thread. If we have a look at the event handler, the callback function of our dialog, we'll see in here where we set our timer in the initialization routine. Well, in here we're going to create a new thread, and we're going to call this function monitorThread, and we're going to store its handle in this global handle. The purpose of this monitor thread is every few seconds to check all the workers. As this thread is kicked off at the beginning of the dialog, it will run for the entire duration of our application and will run quite independently of what's happening on the dialog or what the user is actually doing to the dialog. So let's create this new function. When creating a threaded function, it must take one and only one long parameter. This must be passed by value. So in this one we're passing a mere 0. The purpose of this function is every few seconds to check all of the worker threads to see if anything needs to be updated on the main dialog. So we're going to create a couple of local variables to help us do that. An str message and an str output string. So we're now going to start using some of the functions within our UDP library. The first one is to open the UDP port. If we have a quick look at the library, we will see there is a UDP open port function. This picks up the IP address of the current host, the application running this. It then gets a file handle and opens a UDP port with a timeout of 60 seconds. If there is any error, then the machine will beep and exit the function returning false. Otherwise, it will return true. So if this is true, we can then go ahead and start monitoring. If this is false, we need to tell the user. And we can do that by sending a message to the text activity box on the main dialog. If we do manage to open, we can send a message also to that dialog. So now we can handle both conditions of attempting to open the UDP port. Once the port is opened successfully, we want to go into a loop. And we're going to use a do loop here. Now at some point our application is going to end. the user will click the exit button and close the task leader completely. We need to be able to handle that and close off our monitoring thread. So we're doing this loop until the long-ending global variable is actually true. So when we attempt to end our application, we need to set this variable. So if we have a look at our callback function, down here where we end the application, we need to set this variable. So when the user clicks the abort button, the exit button, this variable is then set to true. And our monitor thread, which is monitoring this every few seconds, will actually trigger. So within this loop, we need to listen for any messages coming in from any of the workers, and we need to pick up what message they're actually giving us. So we're going to use another function within our UDP library to listen. And the return of that function is going to be the message we're going to display. We'll have a look at the UDP listener in a moment. But having got that message back, we want to pick up what's currently in the activity and put it into our str output variable. As there could be quite a lot of messages coming back, we want to truncate some of this information. So what I'm doing here is, once we get the information back that's currently in the activity box, we're taking the last 1,000 characters and we're adding our current message onto that, and we're then displaying that on our screen. We're then sleeping for 100 milliseconds and we're going round the loop again. Once the loop is exited, the user is ending the application, so we need to close down our UDP port. There's an inbuilt function in our UDP library to allow us to do that. So let's have a look at these new functions in our UDP library. First of all, the leader listen. This is very similar to a function we had in a previous client-server UDP demonstration video. We have a number of variables set up at the beginning of the function to allow us to keep track of everything. And our first task is to use the UDP receive command. We basically listen to hear anything coming in on the channel that we have opened. And should anything come in, we'll store that in a buffer. If the buffer has nothing in it, then we'll just exit the function. There's nothing to do. The task workers will be sending us the buffer information in a particular format. It will be pipe delimited. The first section is the host it's attempting to send to. So we will store that in the target server variable. And if the target server variable doesn't equal this computer, then it's not for us. Therefore, our message going back to the calling routine will be the contents of the buffer and the words not accepted. And we will exit the function at that point. If the target server does equal the computer we're sending to, then we then pick up the second parameter, which in this case is the computer that's actually sending us the message. This will be the task worker core. And its final parameter is the status. And as long as we've had no errors, we will continue. So in our statuses, we have a number of things we can actually do. So if the task worker sends us active, we need to work out, do we as the task leader have a new task for this particular worker? So we'll have a function which will work that out. We haven't written this function yet, but we will create a stub for it. If there are no tasks for this particular machine pending, we will send a message back to say we accept that the task worker is active and we have nothing for it to do. And we will display the message to say this machine is currently active. There will be other statuses of processing and completed. And I've created stub processes for each of these. These at the moment do nothing at all. This allows us to test the bulk of the application, and we can go into the detail later. So one of the things you will have seen in this function is that we're testing the target server, which comes back from the worker, against this variable. This is the name of this current computer. So we will need to populate this variable at the beginning of our application. So if we go back to our pb main function, before we actually get down to displaying the dialog, we want to pick up the current computer name. And this comes from this function here, PC computer name, which is another function within the UDP library. So it's quite simply pulling back from the environment variables the name of the current computer. This is a very easy way for working out what the computer name is. Much of the code we're putting in here, as we've said before, is going to be stub processes. These will be fleshed out, or even completely changed, later on in the project. We just have to do enough to prove that the part of the application that we're currently developing is actually going to work. So let's try a compile to make sure we haven't missed anything. And it compiles cleanly. If we try running the application, the fact that we're actually opening a UDP connection, the firewall is actually going to kick in at this point to tell you that it's blocked some features of the task reader application and wanting to know if we want to allow access to this or not. In this case, we will say yes. And now our task leader is currently listening for anything coming back. As we haven't created the task worker yet, at the moment there's nothing for it to listen to. So let's finish up, exit out of this, and we will create our task worker application. So as I said, we're going to create the task worker as a PowerBasic console application. And here we are in the console compiler. So we're just going to create a very basic program, and we'll do a quick save on this one. I'm going to call this one CC Task Worker. This is purely my own naming convention. I usually prefix all my console applications with the letters CC. That way when I see an executable that starts CC, I know it's a console application and will launch a console window rather than the dialog. So we're going to add two libraries to this one, the standard Windows 32, and we're also adding our UDP Comms library. Now for the moment I'm going to create a constant in here, which is the target server, which is the name of the computer that's going to have the task leader application running on it. Now, although we're hard coding it into the application here, we're probably going to hold this in a configuration file at some point in the future. But for the moment, this will do us nicely. We're also going to set up the same enumeration for the condition: active, processing, and not active. The plan is that this worker application will launch a number of task applications when it comes time to do the cluster processing. And depending on the number of processors on the computer, it's going to be launching one of these task applications for each processor. So if we have a 4-core machine, it will run 4 processes. If we have an 8-core machine, it will run 8. So I'm going to create a global variable to store the number of processors. And in our PB main function, we can start to populate it. I'm going to create 2 local variables, one for the message we're going to be passing back, and one for the core number. So first thing to do is to populate the name of the core server, the one on which our task leader is going to be running. And we will populate 2 global variables, one for the number of processors and one for the computer name. The computer name function is the one already existing in the UDP Comms library. However, we have nothing yet that determines the number of processors. However, this is another environment variable, so we'll create a small function to return the number of processors. So having got that in place, what we need to do next is to display something on screen, just for the purposes of debug. Normally these workers processes will not be visible to anyone. But since we're going to be doing a fair bit of debugging and testing, we might want to see what's actually going on. So the first thing I'll do is to display on screen in the console the name of the computer and the number of processors it has. So I'm going to set the color to be an amber color and the background to be black, and we're using the prefix command to save a bit of typing. We're putting out to the standard console output the word launching and then the computer name, and then with and the number of processor cores. And to allow us to see something on screen long enough, we'll put a sleep command in for 4 seconds. So we try compiling that. That compiles quite cleanly. If we try running it, it will run quite nicely, tell us the name of the computer we're running on and how many cores it has. So that's the beginnings of our task worker application. So since we know the number of cores on this particular computer, we're going to be launching messages back to the task leader for each of these processing cores. When we do this for real, we'll actually be launching a thread for each of the processing cores to allow us to launch one task application for each of the threads. So we're going to use a for next loop. So for core number 1 to the maximum number of processors. So how do we send a message back to the task leader via UDP? Well, there's another function in the UDP library which we can make use of, and that is the query UDP server. It takes a string as its single parameter. It then works out the IP address of the computer we're currently on, and it will then work out the IP address of the machine we wish to send to. It will then determine a file handle and open a UDP channel. And we're going to be sending a buffer, which will be the name of the computer we wish to talk to, the name of the computer doing the talking, and the query itself. Again, this is just testing code. We may change this later on. And further down in the code, we have our UDP send command, which is sending our buffer off to that address. And we're waiting for a response on a UDP receive command. And once we get that response, we're using that response to respond back to the calling routine. So we're going to make a call to this function. So this will be our task worker telling the task leader that it is active and awaiting work to do. So if we try compiling that, and it compiles quite cleanly. So in order to test this, we need to run the leader and the worker applications on different computers. The machine we're on now is a computer called Octal2. We're going to spin up another machine and we're going to put the process on that. As we saw in the design video, there's going to be a common storage area, and this is eventually going to be where our applications are going to sit. So I have created a shared folder on another machine, disk 001, in a folder called Cluster Processing and a subfolder called Task Worker. So we're going to copy this process, Task Worker exe, which we've just compiled, into that common folder. And this is where our second machine is actually going to be accessing it from. So we're now connected to Quad 004, which is our second machine. And if we go into the Cluster Processing folder, Task Worker, there is our Task Worker. So let's see if this will actually function. If we launch our main application to listen, this is the task leader listening. And if we go back to Quad 4, which is going to be running the Task Worker, and kick it off. Now, there is our Task Worker running quite happily. It has come up to say it has 4 cores, and it's sent 4 messages off to the task leader. And the task leader has displayed on screen the fact it has received 4 active messages from the Quad 4 machine. So we have now established a UDP link between 2 separate machines. We have the task leader running on our Octal 002 machine, and we have the task worker running on a Quad 004 machine. So using this process, we should be able to add additional machines. See, here we have another machine called Octal, which has 8 processors, and it's showing 8 active statuses. So in summary, we have created a task leader process running on one machine, and with 2 separate machines, both running a task worker process. And we're receiving back messages, 1 for each core of each worker machine. So this is the foundation of our cluster processor. In our next video, we will add a grid to this task leader process to allow us to display in real time the status of each of our worker processes. But that's it for today. Thank you for watching.